although they are going to be the most efficient and they're going to give you the highest contrast, the downside to it is that you have to be nearly perfect. Your margin of error becomes more narrow as your grid ratio increases. Okay? Your margin of error is going to get more narrow as your grid ratio increases. What else is the downfall with higher grid ratios? Higher technical factors, good. Okay? So those are your two negatives with higher grid ratios. Higher technical factors, and what was the other one? Narrow margin of error. Okay. Angulation occurs when there's an angulation of the grid or the X-ray tube. You're going to have decreased density across your image. Centering. Again, you want to be right in the center of your grid. If you're off center, you're going to have decreased density across the film because, again, your beam is divergent and it's not matching the lead strips. Okay? So again, it's going to be decreased density across the image. Again, centering is more critical with higher grid ratios. Narrow margin of error. Upside down grid, you're working so fast, okay? You just had a bad day at work, you're not thinking straight, you haven't had lunch yet. You're gonna go shoot your portable, you put your grid underneath, but you're not paying attention of whether or not it's upside down or right side up. Okay? Are you still gonna get an image? You're still gonna get an image, but you're gonna have grid cutoff or decrease in density on the periphery of your image. Okay? Notice that the slant is going the other way. It doesn't match the divergence of the beam. All right, and then we have the parallel grid. Okay? Non-focus grid, the strips are upright. You're going to have peripheral grid cutoff if you don't match your grid radius. Remember your grid radius? Grid radius is right here, your suggested SID. Okay? So with this parallel grid, you should match the grid radius. If they say 40, try to stay as close to 40 as possible. All right. Grid specifications. All grids will have a label displaying the following specifications. Like I said, when I'm looking at the label in here, here's the label. 10:1. My focal range is going to be between 36 to 40 inches. My grid radius is going to be 40 inches. Okay. My K improvement factor, what do we know about K improvement factor? What's going to give us better contrast, higher or lower grid ratios?
Higher.
Higher grid ratios, right? Frequency refers to the number of strips for a given length. Ratio refers to height over distance. Okay? So again, with higher grid ratios, it's good, but higher technical factors, narrow margin of error. With lower grid ratios, okay, we don't bump up our technical factors that high, but our resulting image should be good, right? But it's not as great as a higher grid ratio. And then lastly, before I let you guys go, is known as the air gap technique. Let's just say you get called into the emergency room. You forgot to bring a grid. It was for a chest x-ray. Let's just say for a chest x-ray, but you didn't bring a grid. Well, I can easily correct that by not running back to the department and grabbing me a grid. I am going to employ what's known as an air gap technique, where I am increasing my object to image distance, the distance from my object to the distance of my image receptor. See this gap right here? Okay? So as your primary beam penetrates the patient, the remainder photons is going to be both scatter and primary. The scatter radiation, or the weaker scatter radiation, is going to be absorbed by air, okay, absorbed by air before it interacts with the image receptor. And what I mean by absorbed by air, I don't necessarily mean it's being absorbed by air. What I'm saying is that as it travels further and further away, the intensity of the beam starts to decrease with each interaction of the air molecules.
So it just deflects off the air molecules?
Right. So by the time it does reach the film, or it may not even reach the film, but by the time it reaches the image receptor, it's too weak to even penetrate your image receptor.
Does that cause blur, though, or magnification by doing that?
Bingo. Bingo. Whatever you want to say, okay? Because of the increased OID, okay, you're going to have increased magnification and loss of detail. But you're going to have a nice black and white image.
So that's just like you're moving quick, you got to get it done.
Yeah, exactly. But it behaves like a very low grid ratio of 5:1. It's improving your film. Okay, it's not very well, but it's like a grid. Okay, that's if you get too lazy to go back to the department and get a grid. I just go back and get a grid. Okay, avoid all this magnification and loss of detail. All right, guys, any questions? I think that's it, right? Okay. So we have a quiz, not a quiz, a test on the material we just covered. Grids and beam limiting devices next week.
Oh, so it'll be a test?
It's going to be a test.